was we always get the question about what premium do we have to pay for a mass timber warehouse? And of course, the easy answer is you don't have to pay any.
If you think the case for mass timber industrial buildings is just carbon, you're missing the real opportunity. It's about fixing the design failures owners are tired of dealing with. And today's guests, Kyle Freres and John Bradford, are right at the center of that shift. Kyle is a VP of Freres Engineered Wood, and they're leading wood innovation with their mass ply panels, a material that's solving real design and cost challenges for developers and owners chasing smarter, climate-conscious building materials. And John is the Director of Structural Engineering at Crow Engineering, and he's one of mass timber's most trusted minds. With decades of experience designing heavy timber structures for industrial, manufacturing, and logistic projects where performance isn't optional. This isn't about making warehouses prettier. It's about solving real problems, faster builds, more flexible designs, and lighter carbon footprints that are already reshaping how developers think about industrial construction. In this episode, we cover a real-world case study on how Freres built their 58,000 square foot mass timber warehouse, what worked, what they learned, and how it stacked up against steel and tilt-up concrete. We also got into the specific ways mass timber solves industrial pain points and why design teams need to think differently to unlock those advantages. Last, we went into how faster schedules, smarter grids, and embodied carbon wins can help AEC teams lead stronger conversations with their developer-owner clients. If you're working with owners that are frustrated by current industrial projects, this episode will arm you with new angles and sharper tools to help. But before we dive in, early bird pricing for the Mass Timber Group Summit is ending soon. If you want to be in the room where these kinds of real conversations are happening and not just listen to surface level panels, you need to be there. You'll meet leaders like Kyle and John, get deep into real project lessons, and connect with developers, engineers, and builders who are actually moving this industry forward. And because you're a podcast listener, you get the hookup. You can use code PODCAST, all caps, at masstimber.group to save $50 off your ticket. Don't wait. The early bird closes soon, and we do expect this thing to sell out. So with that, let's get into it.
Yeah, my name's John Bradford. I'm a senior structural engineer with Crow Engineering out of Beaverton, Oregon. I have been designing timber structures my entire career, which is about 50 years now. And I kind of stand on the shoulders of some mentors that have been designing timber structures for decades before that. So I have a lot of experience in timber design, designed a lot of roof systems, warehouse systems, truss systems.
I'm Kyle Freres. I'm Vice President of Operations at Freres Engineered Wood. We're a family-owned business that's been around for over 100 years. I've been working in my current capacity for the last 20 years, and I've put up a lot of pre-engineered metal buildings around our different properties. And ever since we got into mass timber, I've been excited to build wood structures of our own. I love to see the benefit of building wood buildings and replacing steel and concrete in any fashion they can. I've actually supervised probably some of our largest capital improvement projects, including a cogeneration plant back in 2007, the construction of our mass ply facility in 2017, and lately, or my last project was to build a 58,000 square foot warehouse out of our MPP product at our Plywood facility.
Great. Well, thank you both for joining me. We're definitely going to unpack the project that you guys talked about and worked together on. Really quick, I have some questions for each of you, and I'll start with John. So John, with your decades of experience as an engineer, what are the core considerations that you think engineers need to bring to these larger scale industrial buildings? Like whether they're evaluating what it's going to be used for, what it's going to be made out of, et cetera.
Well, there are several things that go into one of these warehouses, and the basic premise is, what are you going to use the building for, and what's important? Are clear spans important? Clear heights, what's important? So those issues are always important when you're designing facility. But it's also functioning of the building. How does it handle situations like if you have a fire? Does it Does it go up quickly, or does it have good resistance to fire? Does it have the ability to stand up against abuse and that sort of thing?
And Kyle, from the manufacturing background, and obviously we're going to talk about mass ply, how does mass ply address some of those concerns that John just talked about, whether it's from fire, clear span, use and abuse, et cetera?
Well, our mass supply product has been tested obviously for fire rating, just like any other mass timber product. In fact, mass timber products in general have been tested extensively for fire issues. We have a 2-hour fire rating on our products um, for many of our products. And so fire is largely not the concern that you have in mass timber buildings. And it makes sense. I mean, if you had a stick frame structure with a bunch of small pieces, you can see how fire would be a concern. But with the pieces of wood that we're talking about, and as massive as they are, they char, but they don't lose their structure quickly. As far as some of the other issues I see with pre-engineered metal buildings that I think mass timber solves. I think we have insulation issues with pre-engineered metal buildings. You typically have a steel shell, a sheet metal shell, and between that and the girts and the purlins in the building, you typically have a roll-in insulation that is hard to maintain. It takes abuse over time. It looks terrible, and it's hard to maintain. It gets dusty and dirty. You can't pressure wash it because it'll come apart. So I think there's insulation issues with pre-engineered metal buildings. I also personally don't like Z-girts and purlins on pre-engineered metal buildings. For wood products facilities like ours, which generate some dust and debris, those purlins and girts end up being places for a lot of dust and debris to accumulate and become a fire hazard. So I like the fact that a lot of our buildings, you can design them with either a limited amount of girts and purlins, or at least reduce the amount of ledges and nooks and crannies that you might accumulate dust and debris.
John, I saw you shaking your head as Kyle was talking. What are your thoughts?
Yeah, we do get a lot of complaints about dust ledges in buildings for the fire potential, but also, in a warehouse building, it seems kind of might be surprising, but you get a lot of black dust in warehouse buildings, and it comes from the tires on the forklifts. And you have horizontal surfaces, they will just get covered with this black surface. And then your insulation on a metal building, same thing. So that is an issue, and it is something that that is solved with the mass timber wall. But of course, a tilt-up building, concrete building, solves that also. But with the concrete tilt-up buildings, there's other issues. One of them is insulation. Concrete has no insulating value, so now you got to come in. If you got even a semi conditioned building has to have some insulation on the walls. So now you got to hang insulation on the sides, and you've got the same problem that you have in the pre-engineered metal building with that loose insulation. The advantage we have with the mass timber, if you have 4 inches or more in thickness on that panel wall, we can show that it meets the mass criterion for energy, with the energy code, and plus it has R value. So we can actually meet the qualifications for a semi-conditioned building without even adding any insulation to the walls. And so that's a real big advantage.
Got it. And I'm picking up on a lot of different comparisons that you guys are using between different material types and how mass timber, or specifically mass ply, can help alleviate them. Before we get into like the specifics of some of the projects you guys have done and the considerations that we need to take, I kind of want to zoom out a little bit and talk about why this conversation is timely, like why mass timber and industrial uses now versus, let's say, 5 years from now, 5 years previous, et cetera. I'm hearing a lot from my conversations with AEC teams about different asset classes, projects getting put on hold, office, certainly, some multifamily, depending on where you're at. From your guys' side, what are you seeing from the clients in industrial demand compared to those other?
Well, I think one reason that this conversation is very timely is really due to the discussion of tariffs in the last couple of months. Obviously, there's been a lot of discussions about tariffs and tariff barriers for products entering the United States. And one issue that we have heard is that people are concerned about the pricing of pre-engineered metal buildings going forward due to the fact that a lot of the steel is sourced from outside the United States. So I think the fact that people are looking local as a way to potentially hedge these tariff issues and potential currency exchange issues is a smart idea. And obviously, I think looking local for these projects as well is also good for sustainability as well, because you can reduce the transportation and all the carbon issues associated with transportation. I think the other reason that this is a timely discussion is because a lot of these larger tech companies are really looking for a way to improve their sustainability, and a lot of them have needs for industrial facilities, industrial warehouses, which could also lead to helping to inform them on data center design as well, which they're very interested in.
That makes a lot of sense. John, do you have anything to add to that?
Well, yeah, I guess I would just agree with what I'm hearing. A lot of the attention for mass timber has been on residential, multi-story residential office. And those are great applications. But there's been a lot of not near as much attention to the industrial. And to be honest, the industrial warehouse, there's a lot more square foot of that built each year than there are office buildings. So putting our attention there and making use of the renewable resources of mass timber and all the advantages that go with that for carbon sequestering, and that I think just is a good thing for the economy and for our country.
Yeah, I would agree with both of your guys' statements. So let's talk a little bit about the people, or talk to the people rather, that are the ones that are building up these assets, the ones that are paying for it, et cetera, right? The developer owners of these industrial buildings. So we talked a little bit about like the operational use advantages, a little bit on the sustainability story, but I kind of want to unpack that a little bit. So if a developer owner is sitting across from you guys and they say, I'm building, let's use a data center, for example, why would you recommend them using timber in a benefit that translates to them? Is it faster? Is it more sustainable? Is it easier to build? Is it easier to maintain, et cetera? Talk to me from the benefit standpoint from those guys.
I think there's obvious benefits to using mass timber versus pre-engineered metal buildings or concrete tiled just when you walk in the building. I think it's more of an enjoyable space, which doesn't seem intuitive for warehouses, but frankly, it matters. I mean, at the end of the day, a lot of employees for these companies are spending the majority of their day in these warehouses, and it helps if that space is enjoyable. Uh, the other reason I'm actually very interested in mass timber for industrial applications in particular is I think that it's a perfect example of how we can be cost competitive with pre-engineered metal buildings and concrete tilt-ups. And I think in this application in particular, if we can crack that nut on a cost basis, then it really removes the last barrier that people are looking at for developing these industrial structures. You know, a lot of people are concerned about using mass timber. They're dipping their toes in by designing hybrid steel and wood structures where they have, say, steel columns and still use girts and purlins, and they might use wood as essentially an exterior cladding. And I just think that's a shame. I think we can demonstrate, and both on a cost basis and a time of construction and the quality of the building, that you're much better off doing mass timber for the entire structure.
What about from the construction and engineering standpoint, John? What are you seeing as the benefits with mass timber over those other materials?
Well, there's I think several. You know, timber structures and their use as warehouses is nothing new. I mean, this is not a new thing. Timber warehouses have been built for the last century and beyond before that. What's changed is the technology, and it used to be that we could build a heavy timber roof structure with with glulam beams and purlins and, TNG decking, build a great building that way. I designed several of those. But they're very labor intensive, time consuming. And now with the new products that we have with these mass ply panels, we can, erect a 12 by 48 foot sheet in just in a matter of a few minutes. And it's just a real advantage from a constructability point of view. Takes a lot less people. The panel can show up, go straight from the truck right to the roof. It's just got a lot of advantages in terms of time. And the same thing with the wall systems. Traditionally walls have been either concrete or masonry, and those are very, very time consuming. Even tilt up walls, you have to get your slab poured. It has to cure. You have to then lay out your panels. You got to form them. You have to put the rebar in. You got to pour the concrete. You got to let it cure, and then you pick them up. Well, by using the mass ply panels, the panels are already built by the time the concrete's poured, and with just a few days of cure on the concrete, you can start setting panels, and it just can take months out of a construction schedule. And the other thing is, like I say, there have been timber buildings built for many, many decades. And a lot of them are more of a light frame, either 2x material or light open web joist, I-joist, that sort of thing, which they perform fine. They're great, except you get a fire and they go real quick. And even though these buildings don't have to have, per se, a fire rating, because they usually have enough yard around them that they don't have to have that code rating. The reality of it is the faster you lose that roof, the harder it is to fight the fire. You lose your sprinkler systems. Firefighters can't get in or on top of the building. With mass timber, you've got more time there, and the sprinkler system has time to do its job, and et cetera. So I think there's real advantage in that. And compared to a steel building, steel buildings, they're non-combustible, but on the other hand, what sprinkler systems really do is protect the product in a building. And if you lose the ability of your sprinkler system and the heat goes up, you can actually lose the strength in that steel building. And even though it doesn't burn, it will lose its strength and collapse. So you've got a little extra time with the mass timber. I think that's really an advantage that I would see.
I think one thing that, not so much in your guys' world, but from like a layperson's perspective, when people are talking about whether it's, seismic resilience or fire ratings, etc., just because a building is fire rated doesn't mean it's not going to burn. It means it's going to burn at a rate that achieves X, whether people can get out, fire emergency crews can arrive, etc. It's like all these buildings will fail in an intense fire eventually, right? But how and when do they fail, and how is that different? So what I'm hearing you guys talk about is, let's say it's not required to have a rating, but if you're in a PEMB building, the steel members are going to fail at a certain point. You're going to lose their structural integrity. And if you're saying, John, that the sprinkler systems aren't necessarily designed to save the building, they're designed to save what's inside of that. If the steel members holding up the roof go, everything goes. But with mass timber, you'd actually have more burn time because it's got to char through those layers. And that's what's holding up your sprinkler system, protecting the product. Did I get that right?
Yes. And in fact, you can find photographs going clear back to the 1950s. Forest Products Lab put out showing pictures of a building that had burned, and there's a glulam beam or an arch, I can't remember what it was, and over that glulam beam that's still standing there, there's all these metal purlins draped over top of them, and everything else is gone. So that mass effect is really a timely thing. So
well, and this isn't all just theory. Like, you guys are actually building these buildings, and you guys have actually built one for your company, Kyle. Can you walk me through the process of designing, building, erecting, and now using that building, what you guys found in the design process? I know you guys iterated a few times, but tell me the considerations and the collaboration that went into bringing your project together.
Sure. Now that we just didn't decide overnight to build a building. We decided to build this warehouse to store plywood for a few reasons. Number one, we needed the space. What we found over the last few years, particularly after the construction of our mass ply facility, is that we're storing a lot more SKUs than we had before. Of course, when you're storing a lot more of a variety of products in your warehouse, it takes up a lot more space. That and we're having to modernize our plywood operations and our equipment, not only to support the different products we need at our mass ply facility, but also to address the challenges of today, which is one of the big issues there is labor. So we're making a lot of changes to our plywood processes. It takes up more space, and frankly, we needed the warehouse to accommodate both the space for the process changes and the SKUs that we have going in. Additionally, we looked at it as a great opportunity to provide a case study to people, because we always get the question about what premium do we have to pay for a mass timber warehouse? And of course, the easy answer is you don't have to pay any. You know, it is cost competitive with a pre-engineered metal building or a concrete tilt-up, but until people actually see those numbers, it's really hard for them to believe. So we wanted to provide the case study. We wanted to demonstrate to people that it can be done, what it would look like, give them an opportunity to walk through and touch the walls and ask any questions they had, and to be able to provide those cost numbers that they're really looking for. So for the initial design of the building, I have to say that John and I have worked together on a few different structures now, whether that's been different storage facilities or a chipper room, or just prior to this particular structure, we actually designed what I would call like a fire cache. As part of our responsibilities of being landowners and in participating in federal timber sales and public timber sales in general, we maintain a fleet of firefighting vehicles and equipment, and we needed a space for that firefighting equipment at our facilities so that we can maintain it over the winter months when it's not being used, and make sure nothing froze and was ready to perform if we need it on a fire. So John and I worked together to design that building. When we first started designing that first building, what we were really looking at is how do we make this look like a pre-engineered metal building? And in doing so, we designed it to really reduce the amount of wood that we used in the building. So we had columns, we had a portal frame, we had girts, purlins, and we had thin exterior walls of 2-inch wood MPP walls. And we also used an insulation layer on the outside because this is going to be a heated space for our firefighting equipment. And we learned a lot through that process. It's like a great building. It was quick to put up. It just had a lot of pieces. So I think one of the first considerations we went through in designing this warehouse for our plywood was, can we really lean into mass timber? Can we trust in the process of using mass timber? And instead of optimizing for reduced volume in the building, can we optimize for reduced number of pieces and therefore for speed of construction? So that was the first issue we really dealt with in our discussions on the design of this building.
And John, where did you come in, and what were you seeing from an engineer's perspective on how to make this accommodate all those different concerns that Kyle and the Freres team had?
Yeah, we got involved early on, and one of the things we wanted to do is looked at different options of what we can do. And of course, the intent was to use the mass plywood throughout, but there's many ways we can do that. We looked at the system that we came up with, which is basically a posted beam system. We also looked at a full rigid frame type system, spanning a full 140 foot. We looked at a system of building trusses using the mass plywood. All those were viable solutions. And we also looked at different wall systems. We looked at similar to what we had done on the fire cache building that Kyle just mentioned, but which was the 2-inch panels with columns and possibly girts. Actually, I think we were looking at mainly just kind of columns at like 8 foot on center with the panels attached to them. So that was a method. But then if we wanted to condition the building, even for semi-conditioning, we're going to have to add insulation. Plus, you have a lot of pieces that you have to handle and to assemble. So we thought, well, what if we just make the panels thicker and eliminate the subframing? And so that's kind of how we developed that. Now, there's some issues there. If we try to make them meet the L/50 height to thickness ratio, it gets to be like a 7 or 8 inch thick panel, which is grossly overstructured. So we looked at it harder and we decided, we could treat this like we do a tilt-up building or a thin, slender masonry wall and do a slender wall P delta type analysis. Several things we have to take into consideration when we do that, but that made it possible to build this building with only 4 inch thick walls. And it's a 27-foot clear height. The total panel height was 32 feet because we have a parapet. And it just worked out very nice. The roof system worked out with a nice 12-foot on-center grid, which works really nice with a 2 inch mass ply panel. And the panel width for the walls was 12 foot. So it was just a very symmetrical, very efficient system that we came up with. And the base spacings, because we finally settled on the posted beam style system. We maximized the use for the girders at 48 feet, which matches their capacity of their press to create a beam of 48 feet. And we used the full 4 foot depth and then sized it based on the thickness rather than varying the depth. And that made that in a very efficient system. So we just looked for efficiencies all the way through to get efficiency in the framing, efficiency in the use of the material throughout. One problem you can have with CLT or the mass plywood panels, if you're not efficient with the way you set your geometry up, you end up with a lot of waste. And so avoiding that waste is really important in the design process. And I think we were very successful on that. And I think Kyle can probably tell us what he found in terms of the efficiency on this building compared to others that he provides products for. So.
Yes. So on that point, I mean, what really helped is that John is extremely familiar with our production processes and understands the limitations of our product or just the characteristics of the product. So it really helps to design that way. And this isn't particular to our cross-limited timber products only. Every manufacturer has limitations of one sort or the other, whether it's due to the species or the type of wood they're using or limitations of their particular production process. At the end of the day, this particular project was over 92% efficient when we look at going from a gross volume. So how many panels do we make in a gross volume, and then trimmed out with the windows and cutouts and things like that, how much volume were we left with to ship? So over 92% efficient. And I actually don't think that's being overly fair because we purposely put in windows for daylights, for instance, facing the south side to improve the atmosphere in the building. And we actually reused a lot of those window cutouts in other places as well, and that wouldn't be included in that volume.
Real quick, for somebody that doesn't know, where does that 92% number stack up to, say, an industry average?
Well, I wish there was a true industry average. I would say the more creative somebody gets on their structure, typically the less utilization you get out of a building. So if people want a lot of circular skylights or things like that, you're necessarily going to be cutting a panel up and have a lot of waste involved. Now, if you work closely with sales engineers at our company or whoever your CLT provider is, we usually see getting that utilization. If you're somewhere around the 80%, 70 to 80%, you're doing really, really well.
So drastically higher in your case for this building.
Drastically higher.
Got it.
And to keep it in perspective also, I mean, there has to be some waste. I mean, you want openings in your buildings.
Yeah.
You need to trim the edges of the panels to get them clean. You need to, route for splines and things like that. There's a little bit of material that gets cut out always. So, but what you don't want to do is build a 12-foot panel and cut 1.5 foot off of one side and throw it away. I mean, that's just not efficient. And office buildings or residential buildings, more architecturally creative and interesting buildings to say, tend to need to have a lot of that type of geometry happen, and you're going to have a lower utilization. But one of the advantages of using this product in an industrial facility is you have the advantage of, let's set the building size to fit the product, and you can make some minor adjustments, and you come out with a very efficient structure. So,
Kyle, talking MPP versus any other type of mass timber, what about it maybe let's talk about like connections or load paths, things like that, and maybe to tap you in on this too, John. What were you able to achieve with MPP that you might not have been able to achieve as efficiently with, say, cross-laminated timber?
Well, we are a cross-laminated timber product. We like to let people know that, so they realize if they're going to be quoting a CLT project, then we are able to quote any of those CLT projects for sure. We're certified under PRG 320, just like all the other CLT manufacturers are. Our product just happens to be a little different, and the difference there is that we're a veneer-based product, and what that means is that every 1-inch section of thickness of our panel is made up of typically about 9 layers of 1/8-inch veneer. And because we have so many layers involved, and we can actually add crossbands to those 1-inch layers, it gives us a lot of flexibility in how we can lay up our panels for the different applications. For instance, on the beam applications in our warehouse, I believe we use a 2.0E layup for that, John. Is that correct?
it depends on which beams. We used the F19 for several of them. We used the F16 for some of them. And we did not use the high grade, the F21, because that has no cross laminations. And what I was trying to achieve takes real advantage of those cross laminations. So there's that. One of the other things about using the mass ply, I've been designing, like I said, timber structures for decades. And, I've designed many, many, many glulam structures. I love glulam. It's a great product. But it has a few limitations. One, it does shrink. You think of glulam as being a material that's dried and it's not going to shrink like a solid sawn timber. That's true, but it still shrinks. A deep glulam beam can shrink 1/2, 3/4, even 1 inch, depending on the size of it. And you have to be very careful on your connections when you design with glulam, because not only will that shrinkage create a problem, but the problem ends up being splitting the beam. And so that's, one of the things that limited us in our ability to be able to use glulam for rigid frames in the past, because you have to create a haunch connection. Very difficult to do that with glulam because of the whole shrinkage issue and the weak cross-grain tension issue. Literally I tried for decades to come up with a good design, but they all ended up being too expensive by the time I solved all those problems, so it wasn't practical. But once mass plywood came into the picture, I only had to look at that product for about 2 minutes before I already started picturing my first rigid frame. So, with its ability to resist shrinkage by those cross bands, and they'll also resist the cross-grain tension failures with those cross bands, makes it possible to do a lot of things that we can't do with the glulam.
So yeah, a point there that John just made is that, we didn't have a homogeneous grade of product through this entire facility. We had particular grades of product for the particular application. So we had a grade of product for the walls, because that's what they were designed for. We had a different product that we used for the beams in order to get the span we were looking for, and we have the ability to make all those different types of product. We're drier typically. Veneer is a lot easier to dry, as it's almost a 2-dimensional object. It's like a flat sheet of paper. going through a dryer. So it's a continuous process for us. We dry veneer in between 6 minutes and 16 minutes, depending on the moisture content in a veneer dryer, where a lot of lumber kilns take 24 to 36 hours of sitting in a kiln. By the time our mass ply product leaves our facility, it's closer to 10% moisture content, 8 to 10%, which is really a very dry product. A lot of lumber products have a hard time getting dried down below about 16%. They have a difficult time hitting the 12% moisture content that's required by the standard. So that all ends up being a benefit as well.
And so circling back towards the use of the building. So we talked about the construction, the differences, all of that stuff. Talk to me about what your team is saying. We talked about base spacing, all these different SKUs, the atmosphere in there. Like, obviously, as a business owner, like, you're very concerned about like your employees' well-being, how they feel in the space. Like, what's the feedback you're getting from your team that's actually using it?
Well, our team loves it. Of course, the rest of the buildings around our pilot plant are 60 years old. So, driving a forklift into a building that's less than a year old with a new floor and modern lighting and everything else is fantastic. But I have to say that every tour we have given of the warehouse to people coming through, they walk through the door and frankly we hear gasps of astonishment about just how nice the atmosphere is, and it smells like wood, not only because of the plywood that we store there, but also because of the structure. The lighting is fantastic, and the daylights we put in to really improve the atmosphere. It just makes it a very pleasant space to work in.
Got it. And one of the questions or benefits, again, going to that building owner standpoint that we alluded to earlier, obviously you guys care about this because you're in the forest and the wood products industry. And you alluded to a little bit about being a part of the timber sales process, the things and hoops that you guys have to make sure that you're doing to do that correctly. I'm really curious to hear, like, from the tree stand out to an MPP panel going into a building, how can developer owners look at your process, and if their investors or their team has ESG and sustainability mandates, know that those are being met, not just because they're using wood, but because of your process?
Sure. One thing about our operations we don't just buy our raw material from the open market. We're involved from the initial sourcing of the timber, all the way through the processing of that raw material to the production of our MPP panel. So we hire logging crews. We purchase timber sales from the Forest Service or the Department of Forestry or from the BLM. In fact, we're highly dependent on public timber sales. And as part of that, we meet all the requirements of the Oregon Forest Practices Act, which limits the size of different harvest units, but also has quite a few requirements on the environmental side, whether that's on replanting or stream buffers and things like that. We take all those very, very seriously. We plant over 300,000 seedlings a year. After the fires that came through our area in 2020, we salvaged as much timber as we possibly could. Over 70% of the timber that we processed in 2021 that was damaged during the Beachy Creek fire, 70% of the wood that we processed was actually burnt timber. In fact, a large percentage of the wood products that went into the Portland Airport project that is currently still under construction, but they completed the terminal core. A large percentage of that product was actually a timber salvage from those fires as well, which we think is an enormous benefit to the local communities and to provide revenue to rehabilitate those stands that have been damaged by the fires as well. We take the sustainability aspect of our product very seriously. We think we have a very good argument on the use of veneer in mass ply panels versus lumber. And we aren't against the lumber guys. We love wood. We would rather see people use wood than anything else. But when you use a veneer peeling process instead of trying to cut rectangular boards out of a round tree, you're essentially using the characteristics of the tree and that it's round. So if you peel it on a lathe, you get a higher utilization out of that log than you would otherwise. And typically we're over 70% recovery out of a log, which is substantially better than a lumber mill. We also have some other benefits in that each one of our sheets of veneer is an eighth of an inch thick, and we're essentially minimizing the effect of the defects or knots that are in that sheet of veneer by randomizing a bunch of other sheets along with it. So one defect doesn't have an outside weight on the performance of our product. In a lot of different glue lam applications or lumber applications, you end up having to cut out, I would say, a spike knot and then finger join that board back together. All of our knots, all of our defects are part of the performance of our product, and we gain some additional efficiency from that randomization.
Yeah, when we talked with your brother Tyler, it's probably been about a year or so ago, he gave the analogy of like unrolling a roll of paper, right? If you take like a paper towel roll and you unroll it, that's kind of very similar to making veneer, versus if you handed somebody a roll of paper towel and said, cut me out some squares out of this. Like there might be a lot of ways or
That's exactly right.
there's better ways to do it.
Yeah, that's exactly right. And not only that, I'd mentioned that we have about 9 layers for every 1 inch of thickness of our product. Well, every single layer in there, we develop a density number with technology that we've used that's been used in our industry for decades in engineered wood products development. That really gives us a very consistent performance and predictable performance when you engineer these products for a particular use in a building. And engineers like John really need that predictability in order to design a building successfully.
Yeah, and I would like to point out that we at Crow Engineering, we love the plywood, the veneer product, but we love lumber too. We design sawmills and plywood mills. That's kind of our core business. So there's great application for both products. But I really do personally like the mass plywood just because of the characteristics that it has. Like Kyle mentions, it distributes those characteristics, the knots and things. It was drilled into my head way back when I was in college by my professor, John Peterson, that they're not defects, they're characteristics. So it's just the way the tree grows. You work with what you have. But the advantage of the veneers is that it does distribute those, and their effect on the overall product is much less, and you have a much more consistent, predictable product, which is why I'm very comfortable using these panels as a tilt-up slender wall. There's much less variability in a mass plywood panel than there is in a concrete tilt-up wall. And so going tall and narrow with the concrete wall is certainly proved to be possible, and so certainly there's no reason we can't do that with the mass plywood and have even better reliability. So
Yeah.
And if I could just touch on that predictability and the variability and comment a little bit. One issue we've always dealt with is how does our panel end up interacting with concrete in a structure? And we've struggled with this in the past because the tolerances that you're looking at for concrete are typically a lot wider. The variance is a lot wider than you would see in our panels. By the time that we CNC a panel, we're within a 16th of an inch of variance on that CNC. I mean, it's extremely accurate. And what we've seen is you try to set a very square panel on a concrete footing, and it ends up invariably to not sit correctly. So we accounted for that in the overall design of this building by basically providing for shim packs under every 12-foot portion of wall. So before we even set those panels, we actually we shot those shim packs and made sure they were absolutely accurate before we started putting our panels on them. And that basically eliminated the effect of the variability of the concrete on the construction of our building. It was extremely important, and John had designed that as well.
Yeah, and the interesting thing, this panel, the 12-foot panel may have 20,000 pounds on it, but it only took 2 3-inch square shims to be able to carry that. So you put one basically at each end of the panel to get it. But it's end bearing on the panels, and you have great capacity. The panel design is not a function of the strength of the panel. It's a function of deflection, and you want to control that deflection. And that's really the primary thing. If you control your deflection, your strength is going to be considerably more than what you need in most cases. So,
Yeah.
So, John, you know this better than I could, but if you could comment on the effect of having a wall panel and the lesser weight of a wood wall versus a concrete tilt-up wall, I think that's really important for people to hear.
sure, for this building, you probably would have used a 7.25-inch tilt-up concrete wall. It's going to weigh 90 pounds a square foot. Our wall, even with a 1-inch wood siding put onto it, was less than 20 pounds. It's probably about 18. So it's substantially less. And one of the big things about these types of warehouse buildings is in seismic areas is anchoring those walls to the diaphragm. And heavy walls, traditionally been a real problem because they pull loose from the diaphragm, and that's then a failure mode in seismic. So we have a real advantage by using these timber walls by having just so much less weight in that wall, and so the anchorage becomes much easier to accommodate.
Yeah, that's probably a pretty important thing for people to note. Moving forward, what are you guys seeing as kind of mass timber's path into this industrial sector? So like you guys have obviously proved the test case. I know there are other buildings being built right now. What are you hearing from clients in terms of the demand sides? Because we talked about the supply side a lot.
I think there's been a lot of interest in industrial warehouses, particularly if we can standardize on a design that fits a wide array of applications, so we aren't having to get very creative. I think a lot of people are interested in that space, and like I said previously, I think some of that interest is in due to controlling costs that people are worried about increasing due to the market conditions with tariffs. Of course, it's a sustainability issue, but I think also where we're at is the Fed has maintained interest rates at a fairly high level compared to the last few years, and I think there's a lot of project development that is really on hold, waiting for the Fed to make a move. So the projects that can happen at these higher interest rate levels, I think can be very cost competitive. But I think as soon as we see any move in that Fed funds rate, I think we're going to see a boom of construction around the U.S.
John, would you add anything to that?
Well, you need to kind of keep in mind that there's really a couple of different styles of warehouses out there. One is the tilt-up buildings, which we pretty much directly dealt with this warehouse that we built. But the other application is in the pre-engineered metal buildings. They're usually, their kind of advantage they have as it's fairly easy for them to create long spans, clear spaces. And if you're in a building with a lot of racking in it, that's not terribly important. They don't want real close column spacings, but they don't need the big 100-foot plus spans that some of the other facilities get. But some facilities like those large spans, particularly ones that if they're not racked. So now you need to address those also. And we have been being successful in creating the longer span systems with the mass plywood as well. So, you really have both of those types of markets that are available. And I think we're addressing them both. And it's pretty exciting.
Are you guys working on any other projects right now that you could talk at a high level and kind of like what type of applications they're talking about? Like, hey, maybe they're looking for those long spans, or maybe they got racking in them and so it doesn't matter. Like, what are you guys seeing right now from clients in the real world?
We have, a couple projects that we're looking at. One of them is a rack building, but they are still looking for a fairly long span. We're doing it with a beam system, but it results in a spliced beam because of the length limitations on the mass plywood press. But that's perfectly possible to do. We're also looking at another project that they're wanting about 100-foot span, and we're doing that one. It appears a great deal like a pre-engineered metal building, except it's made out of mass plywood with mass plywood, the 4 or 5 inch thick walls, without columns, other than at the or at the rigid frame. And so we're doing a rigid frame that carries primarily the gravity load, still using the fact that we're using the 2-inch timber deck, the mass plywood deck, and the mass plywood walls. We're still designing it as a diaphragm shear wall building, simply because it's going to be more rigid than the frames. Plus, we don't have easy seismic coefficients that we can use through the code, so we just design them for gravity only. But anyway, those types of buildings are things we're working on.
Alrighty. Well, I'm going to ask one final piece of information from you guys to kind of like tie this whole thing together. If you guys are sitting across the table from a developer or various members of the design team, and they were considering using mass timber for an industrial project, what's the one piece of advice you each would give them? And I'll start with you, John.
Looking at the various different aspects that you're looking at, is this going to be a heated building? You want your walls to be able to be constructed easily without having to have a lot of different trades for insulation and that sort of thing. Can you have, is your building going to be a good performer in fire? Is it going to be a good performer in terms of the ecology? And there's really big advantage in using the mass timber as opposed to these other products, because of the ability for it to sequester carbon instead of producing carbon. And I think that's huge for our world in general, but for our economy and our country. I think being able to control that in any ways we can is a good thing, and this is a great way to do it.
What would you add to that, Cal?
Well, I would say if somebody's considering a mass timber project, particularly if on the other side of the desk is a pre-engineered metal building or a concrete tilt-up, that they really need to consider leaning into mass timber. Like I said from the start, if you can design your building to optimize for ease of construction and simplicity and efficiency, I think you're gonna win every time with mass timber. Compared to a concrete tilt-up, our general contractor said we shaved 3 months off of this project. We had a 6-week construction time frame on that 58,000 square foot building, which is amazing. And I think what happens is when you optimize for simplicity and the number of pieces, you reduce the number of picks you've got on the project, you reduce the number of connections you've got on the project, you reduce the amount of fasteners you have on a project, and all that leads to the bottom line. And I think you also need to lean into the mass timber technologies that are out there. The advanced CNC that we have, not only at our facilities, but also have access to is extraordinary. I mean, to be able to hit a 1/16 of an inch tolerance on our fabrication is fantastic. We sent our beams and columns out to 3 different companies for CNC work, depending on their availability and their capability. And we did not have one piece of wood miscut that came back to this project. And I was concerned. I'd had our people out measuring every truckload that came in for the first 3 or 4 truckloads to make sure that we weren't going to get bit with a piece that was incorrectly manufactured or fabricated for this job. And we just could not find it. And I think it's a testament to the CNC technology, the 3D modeling capabilities, and to the engineering and pre-engineering that goes into these projects. And I think people need to lean into it. And if they do, they're going to receive all the benefits.
Those are great answers. Well, thank you both for joining me. I enjoyed learning about the projects you guys are working on, where the industrial sector could be headed, and how mass timber plays a part of it. And I look forward to seeing you guys soon.
All right, thank you.